Good, good. Well, this is the title, as already said, and we would like to start by introducing ourselves. So, Jos, please.
My name is Jos. I think quite a number of you probably know me already as the creator of Object Constraint Language. I contributed UML, wrote a couple of books, and have used way too many different tools to build languages. And I'm currently working as an independent developer for interesting projects.
Okay, thank you. My name is Anneke Kleppe. I also contributed to the object constraint language, and well, the experience that I have is also not easily shown on one slide. So for you, probably the most interesting thing is that I built a code generation tool for UML and OCL. Right, this talk is about Freon. Freon started out a few years ago, approximately 5 years ago, as an experiment to build a projectional web-based editor. Currently, it does a lot more. We could call it a low-code tool, and in this audience, we can call it a language workbench because all of you understand what that is. The name is derived from the Frisian word for friend, and actually I want to show you why we've chosen that name. But first we need to go back to MDA itself. It has been here for a long time, since approximately 2000, and code generation has been in the world even longer. But we don't see any recent tool developments in the area of MDE. Tools like MPS, for instance, tend to be too complicated for most of the developers. I know a number of people that say, well, I can get into MPS, even though it has a steep learning curve, but I don't want to do it because the tool isn't worthwhile for the systems that we need to make in my company. And when you look at Wikipedia, for instance, you can see this quote, which says that MDA is actually dead on arrival, and that was already declared so in 2006. So why isn't this area getting more attention, and attention from larger companies? I don't know, but still my heart goes out to this field, and therefore Jos and I, we decided, well, we have to reach out to a much larger group of developers to get this technology in the interest of these people. And therefore we decided to, well, as the picture says, get down off our high horse, and we wanted to build a tool that is developer friendly. And what that means is that we should be able to build web-based systems. If we do code generation, well, the result of that should be very readable code, code that developers are familiar with. And although we work with languages, and this audience knows all about languages, most of these developers do not. Therefore, we have to define languages in terms of programming languages. Therefore, we don't have multiple inheritors. We don't talk about model-to-model transformations and all other fancy stuff. We just stay away from that. And also we wanted lots and lots of hooks to add handwritten code, because all these tools that help you develop a system, they always have this corner which is not good enough for the system that you are building at that current moment. So we wanted to have something that gives this approach. So this is Freon, but as you can see, it's a bit messy. So let's have a more readable overview of Freon. We have a number of aspects in the system. Of course, we have a language meta model. We tend to use the term language schema because that's more familiar to many developers, but in this audience, we may also call it an AST, abstract syntax tree definition, and that is, of course, the basis for all of our system. Next to that, we have projections, because we started out building a projectional web-based editor. So that's a very core part of our project. We have scoping, we have typing, we have validation, and we recently added an interpreter. And of course, we have to do something about model storage. And for that, we recently linked to LineWeb, which we will discuss later on for a little bit. We didn't quite get down to the level of most web developers. We don't like JavaScript very much, so we use TypeScript. We've worked with React, but weren't very satisfied with that framework. Therefore, we have switched to Svelte about a year and a half ago, and we are satisfied that these two languages, environments, frameworks are doing the job for us. Next to this, these aspects that I mentioned earlier, we have built everything based on a stacked architecture, because as the quote here says, we think simple things should be done simple, but complex things should also be possible. And therefore, we start with the language schema, the AST definition. And on that, we have automatic defaults, so that you can have a very quick start when you are developing a system based on a language. But we also have very simple definition languages, which give you already a basis for tuning, the editor, the scoper, etc. All these aspects that I've shown earlier. But finally, we have the third layer, and that is TypeScript code. Every developer can add his or her own TypeScript code for very detailed tuning for these aspects that are just not right for the system that you want to build. And furthermore, every one of these stacks can be done per concept in a language. If there is TypeScript code, a custom layer for a concept, then this code will be used. If there's not, then we go to the definition layer. If that is not present, then finally we will use the default layer. So that makes the whole architecture very, well, it's complex to define, but it's very flexible to use. Taking into account that we have this three-layer stack, we always start with the AST language schema, which have, of course, concepts or classes, whatever you want to name them. They can be abstract and inheritance because normal developers are used to these kind of things. We also have interfaces and enumerations, but enumerations we extended to being concepts that can have attributes, but concepts that there can be only a limited number of instances for. Furthermore, to build the editor as a tool that is really functional, we've added extra concepts for expressions and for binary expressions. And this is all on the level of defining your language. But when you go to the sentences or the models in your language, we also have a very different approach to most tools. We use model units. And why is that? Well, as developers, we know that you don't write a program in one file. You write programs in multiple files. Therefore, why should you make a model in one file, in one item? No, your model should consist of multiple editable units. And these editable units can specify nodes that can be visible or hidden, and they should be partially, it should be possible to have them partially loaded in the browser. Okay, the next aspect in the tool is the editor. Everything of the editor is based on boxes. We have a library of boxes. We have primitive boxes, boxes that give the user some kind of reaction. For instance, an optional element should not be visible, but it should be possible for the end user to add the optional element. And the third layer is, the third group is the group boxes, which define the ways to build your primitive boxes into larger ones. All the styling in the editor is done based on CSS, again, to reach out to the normal web developer, who probably knows CSS. And the editor has some built-in features, search feature, and of course the undo and redo features. The editor is a projectional editor, and we decided early on that it should be possible to have multiple views in the editor. Every view or projection is prioritized, it's named, and it can be dynamically turned on and off. When we look at the three-stack architecture again, you have the default layer, which is always the lowest, and the custom TypeScript code, which is always the highest layer. But the editor definition itself can be divided into multiple projections. We can have a view with the first priority, second priority, a third priority, etc. And again, the order of things is we start on the top and we work down until we reach the one that is present. Every projection definition, so every view, as defined here, is as much what you see as what you get as possible. The table definition is inspired by Markdown, and we have a number of extra features like action triggers, which can specify what the end user can do in a certain projection. Our approach to parsing and unparsing is that it is actually something like an editor. It's only text-based. So any text-based projection could also be parsed or unparsed. Therefore, we use a projection definition, the one with the lowest priority, or a special one named parser, to generate a grammar from. So the language engineer who is using Freon need not specify a grammar next to specifying the AST and the editor projections. Only the AST and the projections are needed to have a parser and an unparser. Of course, it's always text-based, so we don't handle tables or custom projections. Okay. Fourth aspect is the scoping. I'm looking at the time. I know I have to speed up a little. Excuse me if it's drawing out too late. Okay, scoping, a bit quicker. Default is what everything is referable from everywhere. But when we take the definition level, we can define namespaces. Namespaces are always nested. And sometimes when you have a reference like this one, you simply want to look in its namespace or its surrounding namespace. But in other cases, you want the reference to be referred to another namespace. This is what we call alternative namespaces. Typing, again, the default is very simple because there are no types defined. But when you get to the definition level, the basis is, well, which concepts are types and which concepts have a type. How do you determine a type? And we have simple conformance rules as well. The default validation is a bit more filled. It has a number of default options, but again, in the definition level, you can define type checks. Of course, you need to define typing as well, but you can also define, for instance, the uniqueness of properties in a list. And we can have custom error messages. The latest addition to our tool is an interpreter. Currently, we only have a framework which generates boilerplate code, and the language engineer just has to write one function per concept to tell the interpreter how to evaluate a certain node. It's work in progress, so we need to do lots of things before we really are satisfied with this part. Okay, now for the fun stuff. The demo we've prepared is about online teaching. And in online teaching, we'd like to build web pages like this. We do multiples of unit fractions, find the missing numbers, and we have a question here, and the pupil is able to answer questions. For this, we've defined a structure which is based on topics. Every topic has a number of pages, and we have a flow description. If you are on page 1, for instance, and all answers on the page is correct, you go to another page. And we have some test scenarios because this tool is for building this online teaching environment. So now I give the floor to Jos, who will do the demo.